Hello, everyone, and thank you for being here. Welcome to the 7th episode of our Smart Talk series. Today, we are focusing on a very important topic, cybersecurity. As energy systems become smarter and more connected, it's more important than ever to protect them from cyber threats. The growing digitalization and interconnectivity of smart metering infrastructure bring tremendous benefits, but also increases exposure to cyber threats. Today, we will hear from top experts in the field as we explore the biggest challenges, strategies, and mindsets needed to secure our energy future. Please welcome our guests, Maximilian Urban.
Thank you for invitation.
Vice Chair of the Eurelectric Working Group, Sustainable Network Technology and Information Security Officer at Niederösterreich Netz. René Boringer, Vice President of ESMIG's Executive Committee and co-founder and CEO of Cuculus. And Brecht Wyseur.
Hello, thank you for having me.
Director of Cybersecurity Standardization at Kudelski IoT and board member of the DLMS User Association. Thank you for joining us today. And let's move on to questions for our guests. Before that, I would like to encourage everyone in the audience to actively participate by sending your questions in the Zoom chat throughout the webinar. We can start with first question. What do you see as the biggest challenge in securing smart metering infrastructure, and how can the industry address it? René, you are a software developer and you have solution all around the world, so maybe you can start first to answer on this question.
Okay, thank you. It's of course the most tricky question first, what you can do on the infrastructure. And I have to say, it's not an infrastructure topic. Infrastructure is only one of the components. So we need to see the bigger picture of what we want to achieve. Yes, we are delivering actually all around the world, but as ESMIG, we are focusing, of course, on the European Union. And they have three major goals when it comes to utilities. And that is affordability, very new. Sustainability, everybody knows, right? That is the part where we are incorporating also renewables. And then security. And security is now much more interconnected to security of supply than just, so to say, security of infrastructure. So they have understood that we need to think much broader than what we used to do in the past. So, well, what I think is needed here to address that topic is that we are getting out of a kind of siloed thinking and go into a collaborative mode where different people in the vendors in the value chain are cooperating with each other. So there's our meters, guys who are developing software and solutions behind the meters like PV, EV, and all of that stuff. Then the infrastructure, of course, which we started with here, the back-end systems, software systems, and then also the operation and support of the overall solution. I think that is the biggest challenge here, to get all these things together.
Okay. Thank you, René. Max, what do you have to add?
We as a DSO, we have the problem that we have a lot of smart meters. In our case, it's around about 1 million smart meter out in the field in the county of Lower Austria here. Means that every smart meter is a communication device because, of course, they can communicate. And it's placed at the customer side and we don't know who, and I would even not say it's the customer, but who is addressing this device, which has an interface. It has the H1 interface, the interface for the customers to get data out of the smart meter. So we have a grid with configuration devices, communication devices at the end of the nodes. Around about 1 million devices of that, which we have to control for not being corrupted. And this means that we have, and what we are doing is we have to encrypt the communication with the smart meter, and we monitor the regular communication in order to recognize the malcommunication. So this zero trust approach means learn what is normal, learn what the smart meter normally does and what the customer at his 1H interface normally does, and monitor what's going on to recognize what's wrong or what's the malcommunication or malfunction is. So it's a big topic in the operation because we have to monitor that.
Okay, thank you, Max. Brecht, what is your opinion?
Yeah, maybe I can continue actually on the point that that Max and René have been making. So you're managing like 1 million smart meters you mentioned. So this is a vast amount, but there's utilities that are operating way much more meters and other kinds of devices. So one of the main challenges, as you also allude to, is to manage that complexity. So how do you manage your system, your devices, and all the use cases that you need to implement? So this is the biggest challenge, and actually to address that, I think that was also part of the question. So how could you address that challenge? I'm actually joining René in that observation where you need to avoid or get out of that silo. So you need to have this collaborative mode of being able to address complexity. And the way on how I usually look at that, there's like 3 key ingredients, in my opinion, to have success in addressing complexity. So one is embracing standardization. So I'm very active myself into standardization. That's like most of my work these days. But I'm very strong advocate for embracing standardization so that you can make sure that when you encrypt the data, as Max said, so you need to be able to encrypt data and have the right authentication on that data and so forth. So for that, standards such as, for example, the DLMS user association standard is in DLMS COSM is essential as an example. So that's one, standardization. The second is security by design, like also was just mentioned, for example, by applying zero trust principles. And the third, which is last but definitely not the least important, is to strive for alignment with regulations, having very clear and consistent rules such that you can also then work with your supply chain to have the proper implementations done such that you can have a way to manage that complexity. I think that's the way how things should be working, in my opinion.
Okay, thank you, Brecht. Since you mentioned standardization and regulation, this leads us to the next question. How can organizations balance the need for regulatory compliance with practical business considerations and research constraints? And Max, you are information security officer in the utility, so may you give us answer first.
Yeah, for sure. Thank you. And thank you for that question. The main thing is we as a DSO, we are acting and working in a regulated world. So this means the practical business consideration is equal to the regulatory world to be compliant with the regulatory requests. So this is not a matter of what should I do from what I'm forced or being asked to do. We do that one-to-one. The big problem starts afterwards as we are now fighting to getting the costs for the smart meter security accepted in the tariff fixing by the regulator, because the regulator is controlling our costs. And the regulator is in a kind of a trap. And this trap is they have to accept, and with the network code cybersecurity, they are even the competent authority to define who is a high or critical impact entity in the infrastructure world. So they are requesting the companies like us, DSOs, to be responsive and to implement regulatory requests, especially on network information security. And then, on the other hand, they have to accept the costs. And of course, they try to be a lawyer of the residential customers, of the private ones, for not getting the tariffs increased too much because of that issue. Because we have also other issues as DSOs. So we do whatever we have to do, and we are forced or asked to do. That's fine, but then we have to fight on the costs to get that into our grid tariffs.
Okay. Okay, Brecht, can you add something?
Yeah, I'm always looking at this from the cybersecurity perspective, of course. And so I think there's two responsibilities that are very important for regulators, and which are where utilities need to work together with regulators hand in hand. One is a regulator should be able to shape the framework for incentivizing the market to implement correct measures. And I hope that if they are able to do that in the right way, that this will stimulate the supply chain to implement that at a cost-effective measure. If regulators can make sure that there is alignment at a large scale, by massive scale, I hope cost can go down. While on the second hand, or second responsibility, while the regulator is also imposing a minimal threshold for cybersecurity. We are seeing this in Europe with the NIS 2 and the Cyber Resilience Act. We see this coming, but this minimum bar for security, and I think there's a lot of responsibility for the regulator to put this minimum equal playing field. And I hope that having that can also bring the cost down while enabling secure infrastructure. So I think that's very important, and I hope that addresses also the concern that was just mentioned before from the DSO point of view.
Okay, thank you, Brecht. René?
Thanks also, Maximilian, for that insight. And I would like to add another level of complexity, which is also coming from the DSOs themselves. Right? So we are starting on EU directives, which will be interpreted by a local regulator, and then it will be interpreted again and maybe also added and extended by the DSOs who are making their own decision if that was suitable or not, or how the future could look like. And I think, first of all, we need to understand where regulators should touch the systems, and that's normally where the market is not working, right? Where you have an unbalanced market. So power is only on one hand, but on the other side, the users need to be protected because they have no choice. Like in smart metering, right? They are enforced to adopt smart meters. So then the one who is enforcing that also has to take care that it's secure and that it's not just costing money for no benefit. Right? That is where the regulator is. So there is no bad intention. That's what I want to say. It is actually a good intention to try to protect. And yes, also Brecht, we have the possibility here to unify through standards, through that pressure of the regulator, which will bring the cost down and also increases the success rate, because not everybody is falling into the same traps. On the other side, the regulation is, of course, extremely slow compared to the fast market developments, right? So we see especially in the crypto side, more and more threats coming in very fast, but we have deployed meters which are in the field for 10 or 15 or even 15 years or even longer. So how we deal with that? And the first thing what I've heard also from Maximilian sounds very interesting, right? That's also what I wanted to say. So we need to understand what's normal in the whole system end to end, and everybody needs to give that a little probe points to the operational system so they can understand there's something unusual ongoing, because it will definitely come. And here, I think it would be good for all the regulators to listen more to what has been done already, because we are not alone, even not in the EU, we are not alone in a particular country, not in Germany, not in Austria. And what happens if best practices are not taken into consideration, that we see in the German market, where we are still not flying. Even they have a lot of challenges which could be addressed through smart metering. But the requirements we have set out for ourselves on the security side are so high that the point of affordability cannot be addressed, and so it does not find the way into the market finally through the boundaries set by the regulation. And that should actually not happen, that this holds back a necessary change for the grids.
Okay, thank you, René. Okay, so strong cybersecurity has complexity and costs. So how can utilities balance the need for strong cybersecurity with the complexity and cost of implementation? Brecht, your company is fully dedicated in cybersecurity, so maybe on this question you can give us first answer.
Yeah, indeed. So we're not a utility, but we're a cybersecurity company. So we offer a lot of services on that matter to utilities and device manufacturers, as well as chips manufacturers. For us, it's of course easier to say than for the utilities and device manufacturers to implement. But the obvious answer to how to balance is that you need to realize that when you want to do cybersecurity, the later you implement it, the more costly it will come. The obvious example that everybody hopefully knows is with firmware updates. You cannot do a secure remote firmware update if you have not built in that capability from the start into the devices and the system with proper key management and all the features that you need. If you haven't done that, you will be obliged to go in the field physically to a device to either replace the device or physically reconfigure it. So that's going to be very expensive. So the obvious answer is that you need to think from the beginning about cybersecurity and all the features that you need. So that's the easy answer. But then to elaborate on also what René mentioned, realize we're not alone. As a utility, as a manufacturer, you are not alone. Many people have already been thinking about how to address this challenge of complexity and cost. Also, different organizations have been looking at that. Like with Kudelski, we have been working with the World Economic Forum, for example, on an initiative for cyber resilience in the electricity industry. There's some guidelines over there as well on how to adapt as an organization for properly implementing cybersecurity. I would recommend to look at that as a starting point, but then also look at other utilities and other experienced companies like also Kudelski on how to then do this proper balancing. So keep in mind you're not alone, but think about things up front.
Okay. René, what is your opinion?
I mean, most things have already been said. I'm also, of course, an absolute fan of security by design, and I can just support that example of Brecht. So I've seen many catalogs, use cases, right? What needs to be done, needs to be proven before we go live, and what can come later. And typically you see things like firmware upgrades and key exchange, automatic key exchange as the later stage thing. So the first thing what we do before we go live is just the meter to cache process to get some meter reads to do the billing. And I think, no, it should be exactly the opposite. So first we need to be sure that the system stays operational, even there is an attack or there is a change needed. You can adapt the remaining part later on. So don't move what seems to be difficult to the end. Really think about the impact, right? The worst case really is that we have to send people out to manually update or upgrade meters because of an issue in the firmware we had. The other part is that we need to understand that security is not a one-time investment. Security is a process. So we have to make sure that enough cost and capacity and resource is allocated to maintaining the security throughout the whole lifetime of the system, right? That was also what Maximilian said. So when the system needs to be observed, that's not at the beginning. We need to see how also the usage of data, the usage of meters evolving over time. And that sets a new normal every day, so to say, right? And there must be a lot of automatic processes in the background, otherwise we cannot do that. So thinking about that a system can be kept stable and we have enough information to see if something is abnormal is also a very important requirement which needs to be built in. It looks like it will increase the cost at the beginning of the project because you need a couple of more functionalities, but it will save a lot of costs on the long tail throughout the lifetime of the whole implementation. So it's a good investment.
Okay, thank you, René. Max, what are experiences from utilities on this topic?
Most of it has been already said. I want to start with the last part of your question about how to be costly, affordable by our customers, because they will see the costs in the tariff. That is, we are being controlled by regulators with our costs. So whatever we do, we have in mind that we can have and stay with a strong back in the discussion with the regulator. Well, that's something we had to do, and this was the most costly, most efficient way to go. The second thing is also we had a roadmap of an evolution, like getting better and better each year. We had our certification, ISO 27001 certification in the year 2022, and then we had the surveillance audit every year, which showed that we gained better way, and we gained the efficiency in how to work with the cybersecurity measures to remedy our risk, and all of that was risk-based. So we had a risk analysis. We have a risk analysis every year, but we controlled our measures and our remedies according to the risks. We calculated starting with the high risks and then getting better and better with the lower priority risks. And this is, as it has been said before, this is a matter of time. So we had different steps. We started with big and important topics, and now we get better and better with the next step. So to prioritize what to do first and what to do in the second or third year, that's key here in this case.
Okay, thank you. So we heard a lot about rapidly evolving landscape of technology, regulation, and security. So what do you think is the single most important mindset shift the utility industry needs to make? René, maybe you can first tell us your opinion.
Okay, yeah, good question. So I think we should come to a vision or something which is guiding us, and I want to use again the triangle of affordability, sustainability, and then also security. So if we have that triangle and we are visualizing that also on the utility side all the time, that's where we want to go. That is what we want to improve, and of course they are dependent on each other, right? So what we have already discussed earlier, but that would lead to a top-down approach, so that we are changing the mindset from we are exchanging a technology with another technology more, so that the technology is driving all of our developments more into direction that, okay, that's the goal we want to reach, which technology can help us to get there, and we are also evaluating if that is a good move or not based on the goals we have. And I think this would require actually that we have also in utilities departments which have that end-to-end view on the topic, so that because it's security, it's not automatically moved into the security department or even to the infrastructure and comms department where it's normally ending up, right? And a bit of meter security is in the meter department. So there should be somebody who's looking across all the different departments on the subject. So where we want to go and to make sure that we have a very efficient implementation and making the right decision, what is now important and what is maybe later on important. That would be my recommendation.
Very good. Okay, Max, you heard René's advice or
Sorry, it was not advice, a recommendation.
recommendation. Difference.
And I would like to add something. I would like to add two thoughts. The one thought is be open-minded towards the new technology, which can be threat and mitigation at the same time. All the newspapers and all the media is full with artificial intelligence, and it can be both. It can be used as a threat vector for an incident, and it can be used as a media of remedying risks at the same time. So that's the one thing. Everything which can be bad can be good too. So think about that, and always work on the risk analysis and execute the mitigation. This is a closed loop control. As I said before, we are in a cycle of analyzing, calculating our risks, looking for measures to mitigate these risks, and then measure the mitigation. Is the risk being lower, and do we have to set another measures, or are we fine with that certain risk and the measure and go to the next one? So don't forget that new technology, old technology, it's also a problem for us, very old technology, which is still in the field. And it's completely open to any threat. Yeah, work in the closed loop, like a closed loop controller, and look to the risk, do the measure the measures, and then state if you need some more things to do. And don't forget to be active in this cycle.
Okay, thank you, Max. So, Brecht, do you have any recommendation or advice for utilities?
Yeah, so Maximilian and René already told most of the good recommendations or advice. But yeah, indeed, so there's lots of new technologies. AI has been mentioned, but there's also lots of new networking technologies, like, for example, Thread and DECT NL Plus are also gaining traction. There's also smart home technologies like Matter that is also gaining traction and becoming relevant for utilities as well. With DLMS, the user association, we're also working on new companion profiles for different device types, such as electric vehicles or sub-metering and so forth. Those are lots of new technologies that are coming into the market. Indeed, my recommendation would be that you need to embrace them, see how you can use them, see how you can implement new use cases that you will need to enable better network resilience as a utility. So embracing those, but then also being very realistic. Okay, what does that mean? I gave the example of some new wireless technologies. New wireless technologies come also with new threats. There's new attack vectors that come into the picture. So indeed, you also need to then think about, okay, what are those new threats? What are new risks? And then how do I mitigate them? Preferably by embracing certain security features that also standards bring. And then also the new use cases that are appearing through those standards. So the mindset needs to be to at full best capability, embrace those technologies.
Okay, thank you. Okay, so as we move toward the decentralized energy landscape, how prepared is your organization to adopt zero trust principles and validate the trustworthiness of every connected device? Max, this is the first question normally for you.
Yeah, thank you. Yes, and the question already carries the answer. We don't trust we don't trust any device which does not come from us. So we have a zero trust and not bring your own device strategy. So it's only our own devices we having in our fields, and we allow in our communication network, especially as we're talking about the smart meters, in the smart meter communication network, only these devices, configurable devices, which we parameterize to be able to communicate in there and which have the right certificate. Other devices like inverters from customers or other things we might have to connect for communication, they get their own network, even physical network could be, or at least their own network sector. So we segregate these devices definitely from each other without any possibility to jump in between these communication sectors if they're on the same physical device.
Okay. Tell me if you can add something. You also have control of vendors, manufacturers. Do you have anything to add on from this side?
You mean how we do that? Yeah,
Yeah.
well, as you said, zero trust is the principle, and we don't trust the material we get from the manufacturer. So we have a 100% testing of each device before we put it in our communication network sector or in our communication network. And this is a highly logistics issue, of course. As I said, we have around about 1 million smart meters, which is not much. There are companies in Europe which have much more than that. So every charge of or a sample of smart meters we get into, we do 100% testing in the sandbox, and only then it's confirmed to be implemented or mounted at the customer site. Before that, this will not happen.
Yeah. Okay. Thank you. Brecht, what is your opinion about this?
I have a slightly different view on this. So I agree that in the case of smart meters, you might want to control and verify those before you deploy them. But in having control over any device that would be connected to your system, either now or in the future, it's going to be very challenging. If you think about integration of heat pumps or home car charging, EV charging stations and so forth, I think it's not realistic to be able to have full control over all of those devices. So if we want to think about zero trust in that context, zero trust is actually thinking about how can I secure my system, even if I assume that the adversary is on the network. If an adversary might have control over certain devices, how can I still have security between all the other devices that I still trust? And to be able to manage that, I strongly believe into a third-party certification, for example. So if you could have a certified device that has been verified, that comes onto your network, how can you trust that, and how can you build secure systems based on that assumed trust without having a cascade effect from a security point of view on other devices if that trust will not be correct? One thing, so to your question of how prepared are we, this is something that we're working a lot on at the DLMS User Association. So we are working on new concepts of commissioning and device attestation. So in the new specification that is released this year, for example, we have the attestation feature now, where you can actually verify if a device has been DLMS certified, and you can also know if that device is, for example, a heat pump, or it's an EV charging station, or it's a smart meter, or a gas meter, or you name it. That information can be obtained in a secure manner, as well as its identity. And once you have secure identity of a device that is unique, you can then leverage that for secure communication, for data protection, and so forth. And so if you then assume security of that identity, then you can build up further your system. And in that sense, I would rather say, okay, if you're a network operator, you can choose to accept third-party certification and say, okay, now there's a heat pump being connected to my smart meter, and I will now implement a use case leveraging those standards. I will leverage a use case for example, peak shaving, and this is something that you can then do, and you can build that up from a security point of view with zero trust principles.
Yeah.
So this, yeah, it's a bit of a different mindset I have than what Maximilian is having, I think. But
Okay, but I think that we see the similar situation in the past, that utility first to start to check all devices by own self, and then later when third-party certification start to exist, then they use. I believe they will be happy if third-party certification exists. But René, what do you think about this?
You're now thinking about this and how prepared we are. I mean, we as a company, we are delivering mainly that head-end solution, which is connecting all of that different types of devices, and we have started very early to name that as an IoT application, not a metering head-end system only, because we have also the opinion that we will see more and more third-party devices entering the grid. And you cannot really take them out, because if you're trying to limit your control over that devices, they can really harm the grid. As an example, for example, the PV inverters. Not in Austria and all the regions as much as it is in Germany, right? But the impact of what happens if this is under control of somebody else, or they are uncontrollable in a broader sense, we have seen in the case of Spain. All right, so somebody will control them if we are not doing it, and then it can hurt the grid, because we're still physically connected and they have their impact. So how we try to prepare ourselves is that we are also supporting functionalities where most of our competitors are saying, no, our clients are not asking for that. So we had actually dedicated keys per meter in our solution, when still the most of the available solutions were having one key per meter. And so also we have now this IoT with an integrated security approach, certificate management and key management components in our solution, which are addressing that problems of the future already, so that you can integrate also EV charging systems, PV inverters, heat pumps, all these components, devices which can really hurt the grid and hurt the supply security, which is one of our big goals. So we think we need to face it in a more open approach than just trying to control everything, because that's indeed impossible from my point of view. Not in long term, and long term means here in the life cycle of a meter. Right, and again, don't forget what we have not built into the meters or in the systems now, we will not have for the next 10 or 15 years in the worst case.
Yeah. Okay, thank you, René. Okay, so we can go with the next question. Before that, I would like again to encourage audience to ask questions in the Zoom chat. We will have the time for answering. And with new regulations and quantum threats on the horizon, how confident are you that your current cybersecurity strategy will still be effective 5 years from now? Brecht, I would like first to ask you.
Yeah, so we talked about AI just before. Quantum is like the next the second big topic these days in research in cybersecurity. So that's something that we are very much working on at Kudelski, as well as in the DLMS User Association. So in both in Kudelski as in DLMS, we are working in close collaboration with regulators on the quantum threat, as well as with the National Institute of Standards and Technology, United States, so NIST. They are the organization basically that is standardizing quantum resilient algorithms. Some have been published already, more are yet to come this year. And so the question is then, okay, how effective will that implementation of those standards be in the coming years, and how much time will this take? That's a big question. You said about 5 years. Would that be effective? I highly doubt that. Looking at in practice at Kudelski, for example, we're implementing the algorithms in various forms, like for example in hardware circuits for chipset manufacturers. Implementations that are resilient against side channel attacks and so forth. It takes time to have those algorithms in the chips. It takes time for the chips to be manufactured, validated, and then deployed in the market. It takes time for device manufacturers to then implement them. It takes time for utilities to procure those kind of devices and deploy them. Next to that, at DLMS, we are also adding these quantum algorithms to the specification. So if you want to have a regulated system with standards that are used, those standards need to embrace those quantum resilient algorithms. So that's happening at DLMS. That will be released next year with the next specifications then. But yeah, it takes time for everything to be there. 5 years, some regulators say you need to be ready with migration plans in 5 years. I think that having that plan ready, that's feasible. And then some regulators also mentioned to have migration done by 2035. That's like in 10 years from now. And we heard earlier today that you have, there was a name mentioning you have devices in the field that are like 10, 15 years of lifetime. If you can only deploy your migration strategy in like 3 years from now, we're already like 13 to 18 years further down the road. So I think we'll need to hurry up if we want to be there fast. That's my point of view, at least.
Okay, thank you, Brecht. René, what do you think?
I would say, if you're asking if our strategy will be still okay in 5 years, I would say yes. If the tools, the tasks, the action points we are taking right now will be valid in the next 5 years, I would say no. So again, I come back, this is a process. So we have to adapt also throughout the next years, and the speed we need to change is going faster and faster and faster. So on the side of the hardware and encryption algorithm, of course, we have limitations on how to get the hardware out into the field, but we have also other mitigations in the software design, in the software side, in operations and monitoring of the solution, where we can act much faster, and we need to invent ourselves very, very frequently to win the race, because the security is always a race and it will always stay a race, right? So we are racing against the attacks, and as soon as we stop, the other one will just bypass and win the race, right? So that should never happen. So strategy, yes. What we do at the moment, what we see, what we're implementing in 5 years, definitely no.
Okay, thank you. Interesting answer. Max, what is your opinion?
Yeah, this is completely my opinion as well as what René said. Yeah, the strategy, as long as the strategy is the cycle, like the closed loop control cycle, which I mentioned before, is look to the threats you are seeing and think of, analyze the risk and think of a remedy, it's fine. So as long as this strategy works, it's okay. The strategy has to be aware of to deal with deep changes in technology like quantum computing, and our consultants talk on the post-quantum time from 2029 on, which is in 4 years' time. I personally, I'm not very convinced that this is true, but whatever will happen, we will see. And if the strategy can take that challenge and say, well, now we are there, what will we do? So are we able to exchange the certificates for the encryption with the smart meters, as we are talking of the smart meters now, faster than the quantum computing can crack the code or can crack the key, then we are still fine. But at some point in time, this will not be able anymore. So the computing of cracking the key will be faster than exchanging the certificates. And then we have to look for something else. As long as the strategy and is aware of that this can happen and we have to think of another mitigation, then we are safe on the strategy side, not safe on the technology side. That is something we will then see later on. But still, the thing I want to say is, don't see cybersecurity as a one-stop implementation and forget. No, this is something you implement and have to run cyclically, analyze, measure what's going on, and then even increase the measures you might have.
Okay. Thanks. Good advice. So we have some questions from the audience. One question for René. Can software help prevent further damage if a smart meter or another part of the DCO infrastructure is found to be compromised?
So yes, it can if it is designed in the right way. So first of all, there I want to go back to what Maximilian said at the beginning. So there should be segregated parts, and there are certain principles also already mentioned, NIST, right, giving recommendations how you can separate your system with, for example, you are trying to use as less protocols as possible between two systems. You are not throwing all the data in one basket. You are trying to have some, let's say, cabinets with only the data which are needed for the processes which are running in that cabinet. So there it can help. And then, of course, also on the monitoring side. So we need to expose much more indicators, what's going on in that system. They should not be black boxes. The software should not be a black box. If you want to learn what is normal behavior, you need to understand also the KPIs of every single piece of software. And that is not usual nowadays. So you often see that vendors are hiding performance parameters of their software. So you cannot identify early enough as somebody is looking from the top down if that this piece of software is now getting into trouble because somebody has occupied it or is misusing it and is trying to do, in the simplest case, a denial of service attack of that component. Right? So their software can really help if it's transparent, if it follows certain principles, and again, if it's also applying a zero trust situation where you, even with the software components in your own area, you should actually protect yourself from the fact that somebody else might have attacked a piece of software, is already inside the structure, and then it tries to take over other pieces as well.
Okay, thank you, René. One question for Maximilian from the audience. How much does the implementation of cybersecurity affect the DCO staff, and what impact does it have on DCO's operational processes?
Well, the impact is incredibly high, I want to say. In the moment, as we are under NIS 1 ruling, still, as we don't have a NIS 2 law in Austria, we have it on European level, I know. I have only the system operation, means the deliverance of electricity and gas to the customers in scope for my information security management system. With NIS 2, the whole company will be in scope, means also the meter to cash process then will be covered by cybersecurity measures. And now the staff for system operation, which is in the NIS 1 regime, has been trained. What are the rule set we want to work on, and how do we document what we are doing in terms of information security came into the company or into this part of our value chain. And then there is a big topic. A lot of people fear or think this is completely crazy. We started to define what we are doing for each other in the company. This wasn't the case before. It's completely normal that we make contracts with manufacturers where we explain what we want to get and how they have to work, but we didn't do that internally. And now we started with that in order to know what is the normal behavior in between the different departments or teams within a department, to learn if there is something abnormal. And this is I always tell my colleagues, this is a new lifestyle and this is a new time. We want to be transparent in what we are doing for the others and what we are getting from them. So this is a high impact on the staff, and it's close to a change project in mentality and in culture in our company.
Okay, thank you. Question for Brecht. Are there any standards that meters and software that DSOs use must comply with to guarantee that cybersecurity is not compromised? And also, is there any accreditation for third-party laboratories, entities that could provide a security certification?
So first of all, if we talk about must comply with, that's highly dependent on the jurisdiction. So unfortunately, the rules are not the same in Europe as in the United States or in Singapore and so forth, unfortunately. Even in Europe, there's different rules these days, like the requirements for meters or other devices that you may have in your network may be different between, for example, Germany or France and so forth. There are ongoing initiatives, however, fortunately, to harmonize that as much as possible. So in Europe, for example, you've got the European Cybersecurity Act that is currently under discussions. So there are some standards that are gonna pop out from that. Today, lots of discussions around smart meter gateways, for example. So hopefully this will yield some reference that can be used across Europe, for example, pretty soon. There's also the European Radio Equipment Directive, which is very soon going to be full in force. So August 1st, the Radio Equipment Directive for all the devices that have some radio connectivity with direct or indirect connection to the internet. All those devices will need to comply. There is ongoing work that I can recommend on guidelines to be able to be compliant with. So that's something that is ongoing that soon can be then referenced in the work. I think you had a second part of your question where you mentioned about accreditation or certification.
Yes, is any certification, third-party certification security?
Yeah, so there are certifications for device security. I think it's also important to highlight that if we talk about security, like for example with different standards, like with the DLMS COSEM, that's a secure protocol. It means it enables secure communication. But DLMS, for example, does not state how you need to implement it for having, for example, secure storage of credentials. Like was mentioned before, you've got certificate, but then how do you protect a private key for that? And for those, you do have certifications of devices. You've got certifications of chipsets. And then soon we will also have reference to certification for under the Cyber Resilience Act. And so I hope that these will be useful if, for example, utility wants to procure devices, they can say, okay, we need secure protocols for secure communication. And then next to that, we want also certification for device security. And then referencing those third-party certifications in the procurement process, that's going to be very helpful to manage the supply chain.
Okay, I think that we during discussion mentioned the importance of coordination between regulatory authorities, industry stakeholders, and standardization entities. So what do you think about that? Are you satisfied with the level of that coordination in this moment? Do you see any room for improvement? I don't know, is anyone who wants to first?
I think we already mentioned a little bit before that regulators are typically not going so fast. So things can go better by having things moving a bit faster and increasing the communication between regulators and utilities and security experts. So yeah, I think there's a dire need to have more communication. And then the thing I would also like to add is that we also want the regulators between themselves to also align. The worst thing that can happen for cybersecurity, in my opinion, is that different regions are applying different rules, and as such, it will be very difficult for the supply chain to implement cybersecurity in a cohesive way. If as a device manufacturer, for example, you need to protect a device in a different manner if you supply in Europe than if you supply in the US, for example, yeah, that's not going to help. So I would also like regulators between themselves, between different regions, to coordinate.
I mean, there's also something going on the EU level with the Purchasing Act, right, where we try to get more emphasis on functionality and security over pricing, because that's also one of the issues what sometimes public tender processes have, right? So they need to they need to make sure again that they're addressing the affordability, which can end up in the cheapest product in the market. So there we need also to touch the procurement processes so that utilities have it easier to select a good quality product, which is maybe a little bit higher in price than the lowest one they can get.
Okay, Max.
Well, as you said it already in the question, we are under the public procurement regime, and that's more or less the bad story. The good thing is that we're not alone, not in our country and not in Europe. So we are grouping together, and we are allowed to group together, being DSOs in a regulated monopolistic area. So we are allowed to group together, and we can ask our manufacturers, the several ones which are in competition towards us, to fulfill certain standards because we require that due to legal requirements we are underlying with. Yeah? So I don't see the public procurement topic as a negative point. I see it as a positive point. Yeah? And we can help our manufacturers to be also a good and high qualitative offer of services at other companies as well, I would say.
Okay. Okay, so we are close to the end of our discussion. I think that we can say that we have had a highly relevant discussion today about cybersecurity. Cybersecurity is no longer a separate domain. It is now an integral component of smart metering and digital utility infrastructure. And I think that we can conclude that organization must evolve rapidly, adopting security by design principles, zero trust models, and adaptive strategies that align with a fast changing threat landscape. So I would like to thank to Max, René, and Brecht. Thank you for joining and for sharing your expertise.
Pleasure.
Yeah, same to me. Thank you.
And thank you to the audience.
See you. All right.